the composition of two functions. So here we have a function f of x, which is x squared, and a function g of x, which is x minus 5. Let's work on the first composition A. So this notation, f of g of x, that's what that says. F of g of x at the point 2 is by definition f of g of 2. So the order of operations here is we're going to take 2, we're going to map it somewhere underneath g, and then whatever we get from this, we are going to map it underneath the f function. And we can do this in any order. Let's ignore what f is for now and just figure out what g is, or rather what g of 2 is. G of 2 is equal to 2 minus 5 minus 3. All right, and now what do we have to do? What is f of minus 3? So what we just did, we created a chain of functions. We took 2, we mapped it underneath g and got minus 3, right? That was g of 2. And then we mapped that underneath f, and we got 9. That was us taking g of 2 and sending it underneath f. Okay, let's keep going. Part B asks for the composition in reverse. So we're going to look at g of f of 2. So f is being done to 2 first, and then the g function. All right, let's keep g on the outside for now and figure out what f of 2 is. F at 2 is 2 squared, 4. G at 4 is minus 1. Cool. So 2 underneath f gives us 4, and then underneath g gives us minus 1. So note, composition is not symmetric. G of f and f of g give you two different things. All right, f of 2. So effectively, we're going to do the function f to 2 twice. Let's see what we get. F of, what is f of 2? Oh, didn't we already do this? Yeah. 4. So now what is f of 4? $16. So effectively, if you square 2 twice, you get 16. Okay. Let's go over here. Let me copy down my functions. F of x was x squared, g of x was x minus 5. I think I had that right. Yeah. So f of g of 7, f of g of 7. This time, let's tell ourselves what f does to g of 7. If you plug in g of 7 into your f function, it's g of 7 squared, right? I just plugged in g of 7 for these x's. All right, now we could tell ourselves what g of 7 is. G of 7 is 2. And 2 squared is 4. Right, so the order of the composition is important. It's important that we did f first and then g, but when you actually solve the algebra, you can tell yourself what the f function is or what the g function is first. Let's do E, g of f at 9. G of f at 9. The g function takes an input, in this case, f of 9, and subtracts 5 from it. Right, that's me plugging f at 9 into x, into the g function. All right, now what is f of 9? 81. Cool. And finally, f of f at 0. F of f at 0. So I'll do the inside first this time. What is 0 squared? Right, because that's my f function. That gives me 0. And what is 0 squared? It's kind of silly. I'm asking myself the same thing. I get 0. Cool. So composition of functions, always think about this diagram. X gets mapped somewhere underneath the first function, and then it gets mapped somewhere underneath another function.